All right. So here is the discussion. Let's start with our very first one, correlation. Correlation, basically, if you talk about theory, we can talk for hours. It is representing the relationship among a few cluster of data, where it sees whether those data are actually related to each other or not. If it is completely related, if it is completely unrelated, it is negatively related, so it compares that particular aspect of a particular data. Forget about that. Let's look at few formulas only, because our for us, we have to solve the question and make some conclusions from it. So conclusions, how to interpret and all, we will talk later after we solve the question. But let's look at the formulas of now. So one of the important formulas is this one. Sorry, no, this one. Yeah, this one. So where what happens is, see, in statistics, there are there will be this type of calculations which looks very a big formula, but the meaning of it, if you understand, it's very easy to remember. Now, see what is happening in the numerator. There is something where we are taking summation of the multiplication of differences of two set of series, where the differences are calculated from by deducting the mean of a particular series from each number. What do I mean by that? Let's take an example and we'll go from there. Um, Suppose we have this question. Okay, calculate correlation or coefficient from the following data x and y, and there is a series given 98765432 15 16 14 and so on and so forth. What we need to calculate whether these two series are related to each other. What do we mean by that? When the x increases, does y increase? When x decreases, whether y decrease, or there is no relation at all? And if the relation is there, how strong is it, right? So that's what we decide when we are talking about correlation. Now here what we will do is, see, I've just put the same data in a tab, in a vertical format, and I've calculated the total of both the numbers. With one side is 45, one side is 108. So mean, everybody knows it is the average of the data, right? Anybody doesn't know mean here? What is a mean? Okay. Now that we know that it is the average of the data, we have simply calculated the average by 5 and 12. If suppose we are calculating how different each number from the mean, what did I say? How different, how much difference is there between each number and the mean? If we calculate, how do we calculate? We calculate 9 minus 12, 8 minus 12, 7 minus 12, right? Like that we do. Yes, everybody agrees to it. Sorry, my bad.
Deepesh, will it not be 9 minus 5?
Yeah, you're right. I was about to say the same thing. So 9 minus 5, 8 minus 5, 7 minus 5, and so on and so forth. Yes. Similarly, for y series, 15 minus 12, for 16 minus 12, and so on and so forth. So if we calculate that for a second, imagine if we calculate that, then we have difference of each number from the mean. Then suppose you calculate the square of those particular differences. Why do you want squares? Because actually the differences come negative many times. So on that basis, you cannot make an analysis. But if you make square, the negative goes off. That is the whole purpose of for which actually the square is done. Now, if you do the square, then you have the total with you. Then on these total, you can do some analysis. Which analysis? What is the basic difference? What is the basic difference among the numbers? How scattered are those from the mean? That's what you did, because you calculated the difference of each number from the mean. Now you're calculating what do you call it, squares, and adding those. That is just summing up the relationship among the numbers about how scattered, how different are they from the mean, because you have taken the differences, obviously. Now similarly, the same with, instead of square, you can also do this between the two what do you call it, series x and y. The difference is, you can multiply the differences with each other. So difference from x series was 4, 3, 2, so on and so forth. For a difference of y series was 3, 4, 2, and so on and so forth. You can multiply these two. 4 into 3, 12. 3 into 4, 12. 2 into 2, 4. So it solves our problem also, which we were just talking about, the negative part. Because what happens is, if you do a negative summation of these x minus xm, what will happen? Can somebody tell? How much will it come to?
It will amount to 0.
Exactly. The reason is we have just deducted each number from the mean of the whole series. That means obviously the final amount will be 0. I'll show you. Let's do that. So we cannot do any analysis based on this, because for every series, these amounts will be coming 0. So the reason we are doing squares or multiplying these two differences with each other, so that we can take those numbers and do some calculation based on it. Now, if we do that, now squares we have discussed, then we can also multiply these two together and we'll have that number with us. Now what we do is, we take the last column on the top numerator and the first two in the denominator. What did I say? The last column in the numerator and the first two in the denominator. I just told you how to remember the formula. I just told you how to remember the formula. Remember it through the table. In the table, how you are doing is, you are putting the series first, then you are calculating the mean, you are calculating the differences, you are calculating the squares of the differences, then you are multiplying the both differences together. Then what did I say? The formula is the last column in the numerator, the previous two in the denominator. Now let's look at the formula once again. If you look at it, this is nothing but the multiplication of the differences. Everybody agrees to it?
Yes.
And these are nothing but multiplication of the individual differences squares. Do you see the square here?
Yes.
So you simply multiply the other two in the denominator and take the last column in the numerator. That will give you the correlation. However, the only change is in the numerator, because you are multiplying two different differences, you have to take a square root also. So there is a square root in the denominator. Makes sense, right?
So
Yeah.
we take square root of the sum of total. So here square root of 60 and square root of 60, right?
Yes. Either you do that or you multiply 60 and 60, then take a square root. That is also fine.
Okay. I mean,
Yeah. So if we calculate like that, we simply do 57 divided by 60 into 60, the whole square root. That would give us the correlation of 0.95. Any questions, please, as of now? So I would recommend to remember the formula in this way only. When we understand the concept and we remember the formula, we don't have to remember too much. Anytime anybody asks, or even the examination hall also, it's there. We don't have to remember, because we have a logic to remind us about the formula. And we can just simply start, preparing the data set. The data set, when I say, I'm talking about this one, and then remember what was the formula. The last column was in the numerator, previous two were in the denominator, and accordingly we will calculate. So that is not going to take a lot of our RAM, basically. So we don't have to remember or by heart a lot of things. So
Dheeraj, can you please tell me tell again the average, how to get the average of mean? And in the formula also we are writing mean n equals to 1. So will this be a difference while calculating it?
once again, let me answer the first question. I'll ask you a little bit about the second one. The first question, we calculate mean. Mean is nothing but the average of a series. Okay. Mean is nothing but average of a series. So these are actually, the total of these numbers is actually coming to 45. Do you see that 45 here? Some? Yes?
Yes. Yes.
Now these are actually 9 numbers. So 45 divided by 9 comes to 5. Average. Simple average. Okay. Similarly, here is the total is 108. Number of items is 9 only. We divide and calculate 12 only. Yes. Now, can you repeat the second question? I didn't get that.
In the formula, it mentioned mean as well, right? I is equals to 1, n equals to 1. So what do you mean by these things?
So, okay, you're talking about the summation formula, the summation sign. So what this means is, when you are doing a summation of a series, now look at this calculation that we just did. Okay, look at this calculation. Can we say we have taken x minus xm into y minus ym divided by x minus xm square into y minus ym square? Can we say that? because that is not exactly what we are doing. We would rather, I will tell you the difference between this sentence that I just said and this sentence I'm going to say. We are rather taking the total of the series for x minus xm into y minus ym, dividing by x minus total of the series for x minus xm square, multiplied by, again, total of the series y minus ym square. So the total of the series is there because we're taking 60, 60, 57, not individual numbers, right? Yes.
Right.
So the total
Yes.
of the series is being taken. So that total of the series is represented in mathematical form by the summation formula, summation sign. So what does this mean is I equals 1. That means, it starts from first item. It goes up until n. How many ever number you have. So it takes into consideration first, then second, then third. I mean, whoever is from software line, they would know this. You introduce a variable, then you increase that variable till the point of another variable. That's how it is again doing also here. So I you are taking as 1, you are increasing it 1 by 1 till n. That's what the meaning of it is. That only. You don't have to go into that much of detail to solve the question, to be honest. If you want to remember only the table part and how to calculate and remember the formula, how to formulate the formula also, that would solve our problem.
Dheeraj, is it a misprint in the denominator then? It should be I equal to 1 to n, right?
Sorry, come again.
In the denominator, is there a misprint? Then I equal to 1 to n, it should be, right? It is n equal to 1 to n.
No, I mean, both are fine only, because
Okay.
what happens is because they have taken xi minus x bar, right? X bar means mean of x, right? Now, however, when they're talking about the normal, what do you call it, x minus x square, x minus x bar square, they're not taking I there. So I mean, it's just that approach difference, that's all. You can say that I should be there also here, because I is also used here. You can say that, yeah, I should be here. I equals 1 basically, n in the top and I here. Yeah, you're right.
Okay.
You can also put it as n. That's not a problem. Those variables and all, it's okay. So if you change the I to n every place, no, that is also fine.
Okay.
Yeah. Okay. Any other questions? Okay, now let's understand how do we interpret the correlation, because he wants us to at least write one sentence or two for every question wherever we are calculating such numbers. Now, correlation, as I said, is the relationship among two series. If something is increasing, whether something else is increasing or not, or if it is decreasing or not. If it is increasing, then at what rate it is increasing. If it is decreasing, at what rate it is decreasing. If you look at it, this particular series, when it is 9 it is 15, it is 8 it is 16. So basically, when your x is decreasing slightly, your y is increasing slightly. X is decreasing even more, now your y is decreasing. Now it has started decreasing. When x is decreasing, now y is also decreasing. Overall, then it is happening exactly the same thing afterwards. After once increasing, it is decreasing now. So there is a nice correlation between these two series. Now, what does this mean? Here is the interpretation. If the size of the correlation is from 0.9 to 1, it is very high positive correlation, 7.7 to 0.9, very high positive correlation, 0.5 to 0.7, moderate positive correlation, 0.3 to 0.5, and so on and so forth. The other side is, if it is minus 0.9 to minus 1, then it is very negative, very high negative correlation. If it is minus 0.7 to minus 0.9, high negative correlation, and so on and so forth. You got the logic how we are talking about. If it is negative correlation, what would be happening? The same relation, what was happening in the first two would be continued. When x would be decreasing, y would be increasing. That is a negative correlation, right? So reciprocal to each other. So however, now that after that, what happened was both of them went hand in hand. If something is decreasing, other one is also decreasing. That means that in the whole series, actually, it remained positive. Positive correlation. Okay, any questions? So what do you write when you have the you have the answer like this, 0.9? What do you write? You write there is very high positive correlation between x and y. You can also explain a little bit. When x numbers are decreasing, most of the cases, y values are also decreasing by almost same proportion also, you can say that. Make sense?
Yeah.
So please do write at least 1 or 2 sentences there. That is just, I mean, explanation is just the, phrasing of the thought that we have at that particular moment. You can write that down. In fact, if I'll tell you one trick, in case you are not figuring out something, write down the formula in language. Write down the formula in language. What do I mean by that? Now, you'd say, this formula we have seen already. What is numerator? What is denominator? Let's write it in the language. Correlation is the division of the summation of the multiplication of the differences of each item to its mean by. Now, numerator part, I have actually phrased it in words. By the multiplication of the root over of the squares of the differences of each item from the mean of both the series. I just told the exactly same formula in language. In case you are not able to write something, no, at least write this so that somebody knows you what you know what you're talking about. Any questions, please? Okay. Now, there is another formula which is very important.
At the end of the sum, every time we have to mention that whether it's a very high positive and all those things we have to mention it, right? Every time?
Not just with correlation, with every question. He expects us to
question.
He expects us to analyze, understand, and write what exactly we have calculated. He has mentioned this many times in the class.
Okay, cool.
Yeah. So, okay. Now, very quickly, there is another formula which is very vital for us to remember. It's another formula for correlation, or I would rather say it is just, another, how do you say, way of representing the same formula. What did I say? It is another way of representing the same formula. I'll tell you how. Okay. Look at this formula now. What happens is, if you this summation of n is equal to I is equal to 1, xi minus x bar square. If you divide it by n, it becomes standard deviation of x series. What did I say? If you just divide by n, that is the actually formula for standard deviation. If you divide it by n, it becomes standard deviation of series x. If you do the same thing here, divided by n, it becomes standard deviation of y series. Now, what we can say is, if we are dividing here by n and dividing here and taking multiplied by n, root n, then it becomes nothing but this formula. Give me 1 second. This formula. Can you see it? The same formula can be written like this also. Exactly same formula. As standard deviation is nothing but whatever is there in this part divided by n only. So if you do the exactly same thing and divide it by n, standard deviation x, standard deviation y, that would also give us the correlation. Now, we are not going to remember this formula. This is not important for us. The important thing is, now what do you say? From this formula, when you take this numerator part and divide it by n, that is the formula for covariance. There is another statistical representative for something else only. That is called covariance. So basically, what does that mean? If you take these as covariance and divide it by standard deviation x, standard deviation y, that would also give us the correlation, which is this formula. So the same formula is represented in many, many different ways. Okay. So that is what is happening. So we just have to remember this one: correlation equals covariance of x and y divided by standard deviation x and standard deviation y. Simple question I have actually formulated. There is no question on this source material. I couldn't find a question also online anywhere. So if the question says covariance of x and y is 45, standard deviation of x is 5, standard deviation of y is 10, then our correlation will be simply 45 divided by 5 into 10. That comes to 0.9. Does that make sense? Any questions?
I think clear.
Yeah. Can somebody interpret this about tell at least one sentence about the correlation?
It is highly positive
Yeah,
correlation.
very true. Very true. It is very
So
very
Dheeraj,
high.
can we Dheeraj, when you said this, can they also give us the table and ask us to do with this? No, not required, right?
No,
It
no,
is
no.
up to us on how I calculate R.
Yeah, very true.
Okay.
Yeah. Okay. So this is a perfect 2 marks question, by the way. Perfect 2 marks question. So, okay. If no questions, I'll move to ANOVA. We are done with correlation now. So please don't try to remember the formula, rather go with the table. What we did again, we took the numbers as given in the question and we calculated the differences of each number from the mean. Then we calculated the squares of those differences. Then we multiply the differences together. Last column is taken in the top. The previous 2 columns taken in the bottom, that is denominator. And accordingly, we calculate. And there is just a root over in the bottom. Just don't forget that. Yeah. And your correlation should always be between 0 to 1. Should always be between 0 to 1. As the case means, minus can be there. Minus can be there. So minus 1 to 1, you can say that. It can be minus 1 to 1.
Doubt.
Yeah, please.
In denominator part, we have the summation of n equal to 1 to n, right?
Yeah.
But is it n equal to 1 or I equal to 1?
I equals 1 actually. That's what I
Okay.
think somebody else also asked.
Because
So
we have xi minus x bar, right? So xi, we okay.
Yeah, you're right. Yeah, very true. I think a small typo only.
Yeah.
Yes. Okay. Okay. I'm quickly moving to ANOVA now. Give me 1 second. Yeah. So ANOVA
covariance,
is,
we will get that value in the question, right?
yeah, you will get the question. Yeah. You'll get that, yeah, for sure. If the covariance is not given, no, you can follow this formula. Simply solve the question through this formula.
Okay.
Yeah.
From how we will get the covariance from there?
No, you don't have to calculate covariance to solve this through this, right? What I'm saying is, if they're not giving covariance, no, they must have given the data here like this. If this data is given, you can calculate by like this. You don't need the covariance, right? Covariance is only needed when your data is not provided. Like I said, just 3 lines of data is given and they have asked you the correlation. In this case, you have to remember this formula. Other than that, you can do it. You can't do it. If the data is provided, right? If the data is provided, then you don't need covariance. Make sense?
Yeah, got it.
Yeah. That's why I mean, you don't have to remember the covariance formula, to be honest. So even if suppose somebody is interested, as I said, I was reiterating that fact. Just look at this formula. From this only you can remember the covariance. This is the numerator that we just discussed. You just divide it by n. This is the numerator, no? The numerator, you just divide it by n and that would be your formula for covariance. Everything is correlated. Yeah, all the formulas. If you understand one formula, you can remember everything else. Similarly, you can remember the standard deviation formula also from, in case somebody is interested. Whatever we took in the one part of this one, no? This part, you just divide it by n. That would be your formula for standard deviation. So again, not needed, but in case you are interested, you can remember that also. Not a problem. Any other questions, please? Okay. All right. Now, quickly moving to ANOVA. What is ANOVA? Basically, often at times, this one actually, sure, I believe has asked us to do in the presentations also. When you take a sample data, you have to understand whether it is actually feasible, whether it is, how do you say, whether you check, how do you check the validity of it? How reliable is it? Absolutely. How reliable is it? Now, how do you check that? What do I mean? What do they mean exactly by reliability? Imagine this, okay? If you have some questionnaire, okay, and one question is about positivity of suppose cricket, okay, same when we say positivity of cricket, something about positive of cricket. Cricket through cricket a lot of exercises is being done. Do you think through cricket a lot of exercises is being done? I mean, it is healthy in terms of from exercise we get a lot of exercise. We tend to do a lot of exercise through that. Now another question is exactly something similar to that in the same line. Okay, what do I mean by that? Suppose another question is about do you think through cricket a lot of people actually lose weight? Okay, so both questions are different, but both are in the same line. Now imagine if a person is answering yes to the first question, he has to answer yes to the second one also. Do you agree?
Yes. That's right.
If he has not, what does that mean? What is my question now? If he has answered yes to the first question, but no to the second question, what does that mean?
No correlation between the two data sets.
No, there is no reliability on the data.
Reliability of the data. Yeah.
Yes. So that's what we are checking here. How reliable is the data? And through ANOVA, we actually check how reliable is the data. Now let's quickly move to the question. From the question itself, we will try to remember all the formulas. So there are quite a number of formulas here to calculate the F value. Let's look at it. So here, let's introduce the null hypothesis here. First of all, whenever you are calculating ANOVA, whenever each time that you are calculating ANOVA, the null hypothesis is there is no difference in means. Again, we can put it in another way. The mean outcome is same across all categories. So you are saying the data is actually reliable, or I can say what I can say, the data is reliable. Okay, your null hypothesis is this one. Now, how do we decide whether we are accepting the null hypothesis or we are rejecting the null hypothesis? Sorry, we don't say accept any times, my bad. Whether we are rejecting the null hypothesis or we fail to reject the null hypothesis, we'll decide after we solve those question. Okay, so here is the series given A, B, C. The values are provided 9, 13, 14, 11, 12, 13, and so on and so forth. The question says to calculate the F value and check the reliability of the data. The question will say like that. How do we do? As in the last question we saw, we will calculate the mean of all the series. So you take all the numbers, calculate the total, you divide it by number of items, it comes to 10, 11, and 12. 10, 11, and 12. Then one additional thing you do, you take the mean of all three numbers also. What did I say? You take the average of these three means also, that will come to 11. Make sense? Yeah, as of now?
Yeah.
Yes.
Okay. Now, what do you say? You calculate this particular mean minus the overall mean. Similarly, this mean minus the overall mean. Last mean minus the overall mean. These differences that we calculated, you are calculating square of it. These differences you calculating the squares of it, which comes to 10 minus 11 is minus 1. This is 0. This is 1. 0, 1. Calculating square of it, it becomes 1, 0, 1. The reason we are doing squares is to remove the negative signs. Once we have done that, then we multiply the NI. NI, what is NI? NI is nothing but the number of items. Number of items, that is 5. In each of these differences, that comes to 505. The total of this is nothing but your SSB. Now, what did we do now? We just remember the formula through the table. So what they're saying is SSB is nothing but your NI multiplied by the differences of square and the total of the series. What did I say? SSB is nothing but total of all the series is NI multiplied by the differences square, which is represented by like this one. So you are calculating the mean first, then you're calculating an overall mean of all the means together. Then we are calculating the differences of each of those means from the overall mean. You're calculating the squares of it. you are multiplying the NI, the number of items, into each of those squares of the differences, that is coming to 505. The total of it, that is 10, is your SSB. Trust me, remembering through the table is very easy, especially when you solve at least 1 or 2 questions. Okay.
For getting the total, you just added it off, right?
Yeah, just adding 5 and 5, 0 and 5. Yeah.
So the number of data points in each of those will be always the same. So that NI is constant, right? It will not be 5 sets of data in A, 6 sets of data in B.
No.
Okay.
No, it will not be. So if
It
you
will not.
actually,
Generally, it will not. Yeah.
if you look the difference here, no, it says K in the top. Can somebody tell what is K?
Total number.
Total number. What is that number?
Total number of items in a particular series.
No, that isn't correct. Can somebody else try? What is K here? K is the number of series. That is 3.
Series, number
Yeah.
of series.
So when you see,
Okay.
this
N
is a summation
the number
one.
of items and K is number of series. Okay.
So if
Got
you
it.
look at it here, there are 3 series. You are just adding 1, 2, 3. Each of these are representing each series, isn't it?
Yeah.
XA, XB, and XC. So this summation is for only number of series. That's what we are doing, isn't it? If you replace I with 1, N1 multiplied by mean of 1 minus overall mean. That's what we are calculating here. Second, if you put I equals 2, yeah.
It's better to say between the groups. We have 3 groups A, B, C. So SSB stands for sum of square between the groups. So that's the reason K comes to 3.
Agreed. Yes, absolutely. Between the groups. How many number of groups you have, that many number of the K would be that. Exactly. Yes.
Yeah.
Agreed. Yeah. Any questions, please? Okay.
That
Dheeraj,
NI
can
is
you
equal
please,
to 5. Okay.
Sorry.
Okay,
No, I was just mentioning if you could write the meaning of K somewhere here while revising, you'll remember.
Okay. Do you want me to write the number or what is the meaning?
The meaning, sorry. Yeah.
Number of groups.
Yeah, thank you so much.
Yeah. No problem.
Yeah, Dheeraj, NI is equal to 5 is the total number of values which we have taken, right? Like
number of items.
Okay,
yeah.
this one. Okay, number of items.
Yeah.
Got it.
Yes. Okay. Now, quickly moving to next one, SSW. Now, why we are calculating SSB then SSW? Because we are supposed to calculate F, because all these will help us in calculating F. We'll see it right after this one. Once you understand this one, no, rest of the formula is nothing. These two, once you understand, rest of the formula is nothing. Let's understand this, what is happening here. Let's look at the table only. From the table, we'll look at the problem next. Now, for each of the items, how we calculated for correlation, no? For each of the items, let's calculate the difference from mean. What do you mean by that? For the series 1, the item was 9, the mean was 10. So 9 minus 10 is minus 1. Next one is 11. 11 minus mean is 10. So 1. Similarly, 13 minus 10 is 3. 9 minus 10 is minus 1, and so on and so forth. Similarly, you calculate for the second series. Similarly, calculate for the third series. Now, the difference between the first calculation and the second calculation is what? In the first calculation that is for SSB, you are calculating the differences from the means from the overall mean. Here you are calculating your difference of each item from the mean of the group. Make sense?
Yeah.
You can differentiate up like that and try to remember through that. So now that you have calculated the differences, you have seen it now 2 times. Every time we calculate the difference, we calculate the square of it. Once you get the habit, you don't have to remember also. Anytime you're calculating a difference, no, then you are calculating the square of it. The reason is to remove the minus sign, negative sign. So you calculate the squares of it, take the totals of all these squares. Totals of all these squares. Take a total of these 3 totals, that will be your value of SSW. I mean, if you consider it through the table, no, now it feels like, why do we remember the formula now? We don't have to, this is very simple to remember how to calculate through the table. Again, I'll repeat that. For each item, you are calculating the differences from the relevant respective mean of the particular group. For the series A, each number minus your mean of each A group. And similarly, you're doing for B group, and similarly, you're doing for C group. For each of the differences, for each of the groups, you're calculating the squares of the differences also. You're taking a total of the differences, then you're taking a total of the difference. That is your SSW. Exactly same thing is represented in the formula if you look at it. For the formula, what it says is Yij. This means each of the numbers. This. Okay. Mi is nothing but your each respective means. Some squares of that, we have done the squares here. Summation of that for each particular series group first. Summation of that is 16